Assalamu alaikum, guys. Today, inshallah, we're going to take the first class in statistics, first lecture, first chapter, data and sampling. So in this class, we will discuss about data. Next class, inshallah, we will talk about sampling. Regarding data, inshallah, after ending of this class, you will be able to define statistics. We'll give a short definition of statistics. Also, we'll discuss why we need statistics. Also, we'll discuss two branches of statistics, and we will talk about some statistical terminology. Short definition of statistics. Statistics is the science of conducting studies to collect, organizing, present, summarize, and analyzing, and draw conclusion reports from the data. That's why sometimes we call statistics is a science of data. So statistics consisting of 5 stages. First, collecting data, and then we move to organize this collected data. Then we summarize, we find some measures from this data, like measure of central tendency, measure of variation, measure of positions, and then we move to analyze this data. Finally, we prepare a report according to these 4 steps, and we draw conclusion regarding this data. Definitely this report or this conclusion will help the decision maker to take the right decision according to the study. So we can conclude the statistics is the main part of any studies, main part for any future plan. Any future plan, any studies need statistics. So sometimes we call the statistics is the mother of science, because statistics involved in all fields. In medicine, we have medical statistics. In engineering, also we have statistics for engineering. In agriculture, we have statistics for agriculture. So in all subjects, all fields, we need statistics. No study without statistics, no research without statistics. That's why statistics is a too much important subject. Now we are moving to why we need to know about statistics, why we study this statistics. Statistics help in simplifying complex data to simple, to make them understandable. So sometimes we get a huge number of data, too much complicated data. So we need to make it simple. How to make it simple? Statistics can help in simplifying this data by graphs, figures, frequency tables, make it easy to be understood from interested readers. We can represent the thing in their true form with the help of table and figure. So also statistics can help us to get data represented in figures or table. Without a statistic study, our idea would be lost. So in order to make things clear, to represent things, to build ideas, we need to statistics. Also statistics help us to build strategics and intelligence policy. So for future plan like 2030, vision of Kingdom, KSA, we need statistics. Statistics help in shaping futures. Also for futures, we need future planning, future strategic, future vision, we need statistics. So statistics give us some shaping of futures. Future is definitely uncertain, but by statistics, we are trying to make it as clear as possible. Statistics try to make estimation and prediction, forecasting about the future, but of course, not 100%. Definitely, we may get some errors, some variables, some feature may be cannot be controllable. So we are trying to make it as sure as possible, like 95%, 90%, 99%, but definitely we don't have 100% about certain about the futures. Statistic, we can divide statistic to two main measures or area or field: descriptive statistic and inferential statistics. And we are going to discuss this in details. Branches of statistics, two branches: descriptive statistic and inferential statistics. For descriptive statistic, this branch of statistics consists of collecting, organizing, and summarizing data in a meaningful way that make it easy to be understood by an interested reader. So, descriptive statistics consisting of only three stages of statistical studies. Just we collect, then we organize, and then we summarize by getting some measures. We call these descriptive measures, such as measure of central tendency. We find mean, we find variance, mode, median, percentage. All this we call it descriptive statistic measures. Inferential statistic consists of generalizing from sample to population, performing estimation and test of hypotheses, determine the relation among variables, and make prediction. Actually, the main core of statistics is inferential statistic, not descriptive statistic. Descriptive statistic just gives some description about something happened, already done, or still happening. Inferential statistic, we collect sample, we study this sample. Result we get in from sample, we generalize it to all population to make estimation. Of course, we will not study the whole population. We study statistic. We get some results, some measurement. We use this to estimate the parameter from the population. Also, we use inferential statistics for testing of hypotheses, for determining the relation among variables, and also for making the prediction. So it is mainly about futures. Inferential statistics use probabilities. Also, we use probability estimation, test of hypotheses. All these the keywords of inferential statistics. The main difference between the two types, descriptive statistics, remain true for population or sample under studies. But inferential statistic results from this sample can be generalized to all population, not like descriptive statistic remaining limited for the sample or population that being studies. Let's see, note the main difference between these branches is inferential statistic. The result will be generalized to all population, while the descriptive statistics, the result will remain limited to the sample or population that being studied. That's the main difference between these two branches. Inferential statistics, result can be generalized to all population. Inferential statistics permit us to use a sample instead of using all population. Inferential statistics used for futures, used for estimation of parameter, used for testing of hypotheses, used for regression by finding a relation among some variables. Also use it for prediction, and we use it for probability, which is also about future. Let's see some example. This example is page 5. The second example in chapter 1. This is statistic percent the social network penetration in Saudi Arabia as the third quarter of 2017. The most popular social network was mobile messenger WhatsApp application with a 71% penetration rate during the same period. This is new statement. During the same period, 75% of the total population were active social media. This means in the third quarter of 2017, the popular network social media was WhatsApp applications with 71%. And also during this same period, 75% of Saudi people used to use social media. So this gives us some description about Saudi Arabia using social media and which social media network is the most used in Saudi Arabia. So this is clearly descriptive statistic. Why descriptive statistics? This study remaining limited to Saudi Arabia in this period and cannot be generalized to all countries. Definitely even cannot be generalized to all period of time. This is only true for this period of time and for Saudi Arabia people. Definitely now is changing, and this is not true for all people in different countries. So it is clear it is a descriptive statistic and cannot be generalized to all other countries or other population. Example 3 and example 15, page 6 and 7, based on Ibrahim electric bill for last year. He expects that he will be paying 200 riyals for each month in this year. So is it descriptive statistics or inferential statistics? It is clear inferential statistics, because according to last year's data, he expect he will pay. So expectation based on last year's information, it is inferential statistics. Last year, total attendance at long-run high schools for football game was. So also here, this is type of description. Total of attendance. This is numbers also represent and statistical descriptive statistic measures. So this is number remaining true for this school in last year, not all schools and not all times. So it is descriptive statistics according to 2030 Saudi Arabia vision. The non-oil governmental revenue is expected to be increased from 163 billion riyal to 1 trillion riyal. So it's not now, it's about 2030. And it is based according to statistics, estimation, this will be increased for non-oil governmental will be increased from 163 billion to 1 trillion. This is estimation and this expectation and this about futures. So it is inferential statistic. A researcher conducted a study concerning the phenomenon of smoking among university students. The results have shown that 4% of students, of university students are smoking, and 3% of them are known as smokers before they enter the university. So this gives us a description about student university, specific university, of course, and specific time, say 2010, for example, or 2015. So it is remain limited to this school or this university at that time when study was conducted. And also this is descriptive measure. Also this is descriptive measure. So this gives us some description about the status of smoking among the students at that university at that time, and this definitely remain limited to this university at that time and cannot be generalized to all university and to all times, even in that university. Try this by yourself, which branch of statistics is used in this statement. Generalizing sample to population in meaningful ways. This is definition of inferential statistics. So it's clear it is inferential statistics. The average life in China is 80 years old. So this gives us a description about the people in China. They look like old, most of them like average 80 years old. And average also is descriptive measures. By 2040, at least 3.5 billion people will run short of water. This Earth's expectation to 2040, future prediction. So it is inferential statistics. Median household income for age of people 25 to 34 years is $35,888. So this is description of the income of people at a specific time, definitely. So also median is a descriptive measure. So it is a descriptive statistics. Activity 1, page 4. The general percentage of SSLS of one teacher of last semester. This is the questionnaire we used to give at the end of semester for assessing teachers' skills. One teacher get the last semester, he get in total 74%. So answer the following question: which branch of statistics is this? Definitely, this is last semester, and this is descriptive measure, and this is about one teacher in specific semesters, and this definitely is specific student, specific course. So this study remaining true for this teacher with this student at that semester. So this is descriptive statistics because it cannot be generalized to all teacher, all students, all subjects, and all semesters. Which is branch of statistics? It is descriptive statistics. Could the result of the study be generalized to all IAU students? No, this cannot be generalized to all. Why? Because it is a descriptive statistic, and descriptive statistic remaining limited to the population or sample that being studied at that study. Activity 2, page 8, a medical center is studying the relationship between smoking and lung cancer. A group of smokers has been selected, their age and duration of smoking and number of cigarettes smokes per day, and the researcher concluded that there is strong relation between smoking and lung cancer. So the question is, this study can be generalized to all population? I can say for all people who smoke, they can get a lung cancer. Yes. So this is remaining true regardless which sample we use. So, and also relationship is keywords for inferential statistics, and this study can be generalized to all people. What is branchal statistic? Is this inferential statistic? Could the result of the study be generalized? Yes. Why? Because it is an inferential statistic, and inferential statistic result could be generalized to all population. So now we are going to discuss some terminology of statistic, key statistical curve. We started with the variable. So variable is characteristics or attributes that can assume different values. So any attribute or characteristics, we assume it different between subjects. For example, your age is different from your brother age. Your weight is different from your friend weight. Your statistic score is different from your friend's score. So this is type of variable. So variable is different. A random variable is the variable which its value are determined by chance. If I come to my class and selected a random sample, for example, then to check, for example, student age from my class, I selected 4 students. So these 3 students is the random variables. The data is the value, measurements or observations that the variable can assume. For example, age is variable, but your age is 18. The value 18 is data. So data is the value of the variable. Collection of data, we call it a data set. For example, student data set maybe include student GPA in semester 1, student height, student weight, student blood type. We call this data set. While each value, each intersection of column is variable caption with instance is 1 student, for example. So this value, we call it datum. Datum is single data value. For example, 19, 18 of age is of 1 student is datum, but single data values. Now we are moving to define population. Population is consisting of all subject, human or otherwise, that being studies. So if I am studying university student, all university student is my population. If I'm studying science track, so science track is my population. Sample is group of subjects selected from the population of interest. Sometimes it's not easy to study all population. So as we mentioned in inferential statistics, we can take a sample and study this sample. The result getting from this sample can be generalized to all population. So in this case, we take a group of subjects from that population. We call this a sample. So sample is subgroup from the population. Population is all subjects that are being studied. This is our target population, for example, and I selected by sampling technique will be discussed later. How to select this? We select this for, we call this a sample. Also, here we have this population is consistent. Consistent, it look like similar. Below, and look same. So in this case, we take this. But if my population is different item, like this one characteristic, my sample should represent all this characteristic. So I should take from this. For example, if I'm talking about the student English level, my study is relevant to English level. So in this case, I have to take one from beginner, for example, some from beginner, some from intermediate, some from advanced. In this case, all characteristics or level will be represented in my sample. We call this sample, and this sample should be representative. Also, this will be discussed, inshallah, in the next class. Parameter is numerical measurement obtained by using population. So any measurement we computed from the population, we call it a parameter. So parameter computed from population, we used to say P from B. Population, from population we compute a parameter. We always denote it like mu, sigma, alpha, beta, it's like this. Is sigma. Sigma is standard deviation computed from population. Mu is the average, called it population average. Definitely we compute it from population. In contrast, statistics, the same numerical measurement obtained by using the sample. So from sample, we compute the statistics, so S from S, denoted by X bar or S for standard deviation of a sample, like bar or hat. Sometimes hat, this means is from, this means we computed from a sample and we called it statistic, not statistics. No, this is statistics. One numerical measure obtained from sample. So the idea is like this. We can explain this in this figure. We have this population. From this population, we selected a random sample. We select this sample. Why we need this? We need this to compute some measures. For example, I can compute average from this sample. So this average can be used to estimate the population average, which is mu. Mu for me is unknown. So how to estimate this? Estimate this by selecting a sample and computing statistics, which is X bar. We use this to estimate the parameter. So we use statistics to estimate the parameter to get some inference about parameter, about population. Here, by estimation, the parameter by the value of the statistic. For example, if I'm studying student weight of university, it is not easy to take all weight of all students, so I can take some of them. I can find the average of this sample, let's say like 80 kg. This 80 kg is X bar, and it is statistic. Why statistics? Because we computed from a sample. Why we need it? We needed to estimate the parameters. Why we estimate the parameter? Because a parameter is unknown. So I can say that we estimate the average of all university student weight by 80 kg. It will not be exactly 80 kg, but will be around 80. So we use statistic to estimate the parameter because parameters are usually unknown. We have example, identify each of the following data set is either a population or a sample, a grade point average GPAs of all students at a college. So we collect a GPA from all students. GPA is a variable from all students. So it is a population, why population? Because we use the whole subjects, which are students. GPA of a randomly selected group. Selected group means sample. The gender of every second means we left the first, we took the second, we left the third, we took the fourth. So we call this like on, off, on, off, on each second. So this is each is every second customer who enter movie theater. So we select a sample from the people or the customer who enter the movie theater. So it is a sample. We have example 8, page 9. Researcher is suspecting there is the relation between student absences and their final grade to check that a group of students highlighted this is a sample are selected from the science track and their score and a number of absentees have been reported under the following question. What are variable under studies? The score, the variables, absent is also variables. In this example, the researcher study the relation between two variables, which are absentees of students from class and their grades in final exam. So variable are students' grades and student absentees. What are the population and the sample? Population is science track. So he liked to study science track, but instead of studying all students in science track, he or she took a sample from science track. So a group of students represent a sample and all students of science track represent the population. The study is which type of study? If we ask, it is inferential statistics, because this study can be generalized. Relation between absentees and final grades is true for all students, regardless which track or which group. Try it yourself, decide whether the numerical value describe a parameter or statistic. Here we have to mention parameter and statistic is the numerical measures. A recent study of a sample of the size of sample student has shown that average monthly income for a student is 500 reals. So this is study conducted on sample or population on sample. So each measure we computed from sample is statistics. This is sample. And this is definitely statistic. As we mentioned, statistic computed from sample. S from S. This is 150 is the size of the sample. So don't get confused. The average monthly income of what? Of all students. All students. So all students is population. and this computed from this student, so it is parameters. Why parameter? Because we get it from population. A variable can be classified in two main types, qualitative and quantitative type of data. So we can classify or divide variable is two types, quantitative, which is numeric, and qualitative, which is non-numeric. Let's see the difference. Non-numeric. This quantitative data is numeric, and this numeric can be also divided to discrete and continuous. Discrete, we get it by counting, no fraction, no decimal. Continuous, we get it by measure. Both are numeric. This is not numeric, like gender, nationality, grades, colors. Qualitative variables are variables that can be placed into a distinct specific category according to some attribute or characteristic. Non-numeric, it's not number, like gender, male, female, nationality, job, student area of residence, خبر تمام زهران طيف قصر, legends, nationality, eyes color, hair color, brand, occupation, letters grade, ASBCs, Ds, type of car, marital status, single, married, blood type, A, B, O, AB. All this is not number, non-numeric. So we call this qualitative or categorical variables. Quantitative variable, numeric, and can be ordered or ranked because it is number. Example, height. We can order student height in class. Also, we can order student weight in class, age, also salary, price, temperature, cost, number of student in class. All this is numeric. Discrete, quantitative type of data, we can classify it into types, discrete and continuous. Discrete assume values that can be counted. Number of students in class, number of car in parking, number of page in statistic box. So we get it by counting. Number of students in class, number of car in parking, number of children in family, number of lamps that factory can produce, number of bedrooms in house, and so on. So no fraction, no decimal. Number of students in class cannot be 30.5, 30, 29. Yes, number of cars also, no decimal, no fraction. Continuous variable assume infinite number of value between any two specific values. They are obtained by measuring. We get it by measure. They often include fraction and decimal value, air pressure, weight, temperature, height, length, blood pressure. All this is a continuous variable. Why continuous variable? We get it by measuring air pressure, by measuring weight, by measure temperature, also height, length, and blood pressure. All this we get it by measure. So we call this continuous variable, continuous type of data. This always include decimal and fraction. Like example, weight can be 80.5 kg. Height could be 169.6 centimeters, and so on. Because continuous variables are obtained by measure, as we mentioned, using different devices, you measure your weight in one clinic, you move to clinic 2, you check your weight. Maybe you find some change. In clinic 1, you get your weight 81.5 kg, for example. In clinic 2, you get it 81.6 kg. Yes, so we have different always in variation in measurements. So we get variation, not that big variation, but still we can, this variation may be due to different of devices. Also weight, we measure weight, for example, by pounds or kilogram. Height, maybe we measure it with centimeter and inch, and also this measurements or this unit cause some variations. So in this case, for continuous variable, we use bounders. Bounders means we have two values. For example, if your age is, say, 18, this 18 could be from 17.6 months up to 18 and 6 months. So 18, if you say my age is 18, I can understand 18 means you above 17 and 6 months, maybe 7 months, 8 months, 9 months, up to 18 and 6 months. But if more than 18, 6 months, this means you are 19. So for continuous variable, because value or recorded value is not exactly, so we can put it in two range. We call this bounders. Any value between these is accepted. For example, if we get height recorded 176 centimeters, this means it could be 175.5 up to 165.5. So we subtract 0.5 just, and we add 0.5 as the recorded value should be in the center between these two bounders. We call this lower and we call this upper. If we have fraction like this time recorded is 0.36. This 0.36, just we concern about last value, which is 6. We can write it like 0.30 and 60. It is same. So this 60 is subtract 0.5. We make it 5. We add 5. We make it 65. So just 0.36, make it 0.3055 up to 0.365. As this value, 0.36, will be between these two bounders. 77.5, same. 7.50, make it, the lower is 7.745, upper is 7.55, as this will be in the center between these two values. So 30 years old means 29.5, same up to 30.5. 25 square meters in 24.5 up to 25.5. 80 kilometers per hour means 79.5 up to 80.5. Let's take some examples. Choose the correct answers. The natural hair color of 20 randomly selected fashion is what type of data? Type of data, we have 3 type of data: continuous, discrete, and qualitative type of data. It's not type of data, of course, just like filler. So what is our variable here? Our variable here is natural hair color. Hair color. Sample size is 20. This is sample size. It's not. So here, is it numeric? No, it is not numeric. So it is qualitative type of data. Age of 20 randomly selected fashion model are what type of data? Age is number, numeric. Yes, numeric could be discrete, could be, say, continuous, quantitative. It's better to be continuous. Better to be continuous instead of. So age, we get it by measuring or by counting. Of course, we get it by measure. So it is quantitative or continuous. The best to write continuous, not quantitative. Amount of gas will input into a car at gas station. What type of data? Type of data, quantitative, qualitative. This also could be, instead of quantitative, we can write discrete and continuous, as in the first example. So not this, of course, and not this, of course, could be quantitative, could be qualitative. Amount is amount in liters, in, so amount is quantitative. And more precise, it is continuous. Amount of time. Amount is, any amount is quantitative. Number, any number is discrete. Number of customers. Of course, number we get it by counting, not by measuring, but amount by measuring. Try it yourself. The height of Khalifa Tower. Height, we get it by measure, right? So it is quantitative and it is continuous. Color, color is not numeric, not number. So it is qualitative type of data. Time it takes to cut, time is continuous. But time in hours, we write in hours, is discrete. What are the boundaries of 15.6? As we mentioned, 15.6, 1560, we make it 55. We add 0.45, we make it 0.65. Add 16.5 will be between these two values. So this is the lower and this is the upper, which is this one. What is the boundaries of 19.10? Same, we subtract 0.5, it become 0.5. We add 0.5, become 0.15. Take care about this. So in this case, it is this one. Is this one? Definitely not this one. Why not this one? 0.5 is greater than 0.115. Now we are moving to the last topics. in this class, which is level of measurement of variable, as we divide type of variable to two parts, which is qualitative type and quantitative type. Now we can divide it according to level of measurement to 4 types. The qualitative type of data, we can divide it to two, which are nominal and ordinal. These both are qualitative type of data, which are non-numeric. The quantitative type of data, which is discrete and continuous, we can divide it to two parts, which are interval and ratio according to level of measurement. So now we have 4 types of level of measurement. This 4 type, nominal just like no rank, no direction, no order. Ordinal, yes, we have order, we have rank, we have direction, and this is more precise than this, more strong than this. This is a weakest one. This is strong than this, but still weak than those. Interval and ratio are both numeric. This is not numeric, so but of course not too much precise and not strong. This weak. This is strong than this because these are numeric and these are non-numeric. So let's discuss in details. Nominal level of measurement classify data into mutually exclusive and exclusive categories in which no order, no ranking can be imposed in the data. No mathematical computation can be made at this level. Like gender, male and female. I cannot say male is better than female or female is better than male. Marital status, married is not better than single, single is not better. Zip code actual is number, but we represent just nominal, no order, of course, no rank, no direction, area of residence, Khobar, Dammam, for example, student, those who live in Khobar is not better than student, just like areas. Scientific measure, statistic, mathematics, computer, English is not better. Statistic is not better than mathematics. Mathematics is not better than computers. Measure. The second type is ordinal. Ordinal means, yes, we have order, we can rank it, we have direction, and it is precise, different exist. Precise, different exist. Example, student grade, A plus, A, B plus, B. Definitely we have direction from the best to the worst. Of course, A plus better than A better than B plus, but we don't have precise difference. For example, between D and F. No precise difference. F could be with 0, while D with B could be with 60. Also could be with 58, 59, for example, and this 60. So we have different, but this difference is not precise different. Also, student English level, we don't have precise difference between beginner and intermediate. No precise difference between advanced and intermediate. But of course, advanced is better than intermediate. Intermediate is also better than beginners. The third and fourth type level of measurement is numerical and is quantitative type of data. Interval level of measurement is numerical rank data, just precise different, of course, precise different because it is numeric. exist. However, there is no meaningful of zero. For interval, no meaningful of zero. No mathematical computation can be made at this level. The famous example is temperature. Temperature zero doesn't mean no temperature, no temperature zero. We can measure temperature and it could be zero. IQ also we can measure IQ and it could be zero, but this doesn't mean zero, no meaningful of zero. Calendar also, calendar zero is no meaningful. The last level of measurement, which is ratio, numerical rank data, where precise difference exists, and there is true zero. Zero is zero. For example, height, if height equals zero, means absent. Age also equals zero means absent. Time means absent. Here zero means absent. For example, salary equals zero means no salary, non-employee. A price equals zero means free, number of students in class equals zero means no student in class. All students are absent. So here we have true, meaningful of zero. Here we don't have meaningful, no meaningful of zero. Famous example is temperature, IQ, and calendar dates. Here we have some example regarding this 4 level of measurement. Nominal zip code. Zip code is number, but actually it is nominal. No rank, no order, IQAMA number, phone number, religious affiliation, Muslim, Christian, Buddhism, hair color, white, black, entry deal code, also blood type, A, B, it's no rank, nationalities, scientific measure, as we mentioned, statistic, math, student grades, yes, academic degree, yes, player rank, yes, job degree, yes, English level, and so on. Here in interval, temperature, IQ, and calendar is the famous. Age, yes. Ratio means we can be compare your age with your brother age. For example, weight, your weight with your friend weight. And here we don't have, here we have real zero. Zero means absent. Number of sale, salary, distance, price, time, number of email, number of student in class, numbers. This is actually all discrete is ratio. Level of measurement. Let's take some example. This example 13, page 20. Choose the correct answer for the following question. Weight of cell phone. Weight is what? This question is level of measurement. So weight is numeric. It could be ratio or could be interval. Zero means absent. So it is ratio. Categorize of magazine in physician office, sport magazine, women's health, men's news. So we have this type of magazine. This not number, non-numeric. So it could be ordinal or it could be nominal. So if we can order, we can rank it, it is ordinal. If no ranking, no order, it is nominal. In this case, it is nominal. Cannot say sports magazine is better than women magazine. Also, women magazine is not better than health, and so on. If they ask about what is type of data, So type of data is qualitative type of data. Actually, nominal and ordinal are both qualitative type of data. Here, if they ask about type of data, it is quantitative type of data or it is continuous type of data. Rank of Goldbars. Rank is ordinal, of course. It is not non-numeric, so it is ordinal, not nominal, because here it's ranking. So if we ask about type of data, it is qualitative type of data or categorical type of data. Temperature is interval. Temperature is interval. Try yourself. Blood pressure of runners in a marathon is what type of data? So here our variable is blood pressure. Question is type of that, not level of measurement. So we have three types of data: continuous, discrete, and qualitative type of data. Blood pressure, it is numeric or not? Yes, it is numeric. So it could be continuous or discrete. How we get it? By counting or by measuring? We get it by measuring. So it is continuous. Type of car. Type is not number. Is an example of level of measurement. So it's not number, non-numeric, of course, not interval, not ratio. It could be ordinal or nominal. Type, no ranking, so it is nominal. Always type is nominal. So we finish, inshallah. We will discuss worksheets in face-to-face class.